Hello friends, welcome back to Online Math. So we have this equation right here to solve, and so we're going to be looking for the value of x that will satisfy this simple looking equation. Okay, and of course it is tricky, but we're just going to be diving into it. But just before we proceed, if you're new to our channel, don't forget to hit the like button, subscribe to our channel, and also turn on the notification icon so that if we release new content, you will actually get to know about it. Okay, and then of course, if you are a returning subscriber, thank you so much. Hit the like button even as we proceed. Okay, so whenever you have this kind of equation, and then of course most times when you are having the variable at the exponent, one of the most natural thing to do will always be for you to take the natural log of both sides so that the exponent can actually come down, and then of course you can continue simplifying from there. So that is actually going to be the first step I will take. Okay, so if I do that, I'm going to be having the natural log of 1 power x is equal to the natural log of 3. Okay, so let me put this in brackets, and then of course I can actually bring down this x so that I have that this is x multiplied by the natural log of 1 is equal to natural log of 3. Okay, and of course you will not actually go far for you to see that there is a problem, because the natural log of 1 here is 0, and so when you have 0 multiplied by x, it's actually going to give you 0, and then of course natural log of 3 is not equal to 0, so which shows that we cannot find a real solution to this equation we are solving. So it is not difficult for you to see that, because if you pick out of the real values of x and put right here, there is none of them that is actually going to satisfy this. Okay, so but how are we going to be solving this? All we just need to do is to find a way to extend our solution to complex number, and that is when we can actually be able to find a solution to this equation. So how do we do that? You just need to remember this as a polar exponential equation, that is exponential I theta, which is defined as cos theta plus I sine theta. If we substitute theta equal to 0, so picking that, we're going to be having exponential I times 0, which is exponential 0. It's now going to be giving us, this is cos 0 plus I sine 0. Okay, so this is 0, and of course this one is equal to 0. 0 times I is 0, and cos 0 is equal to 1. We can also consider another one. Let's say theta equal to 2 pi. So if we put that right there, what we're going to be having is exponential I 2 pi. Okay, it's now equal to cos 2 pi plus I sine 2 pi. Okay, and then of course this sine 2 pi is also equal to 0. 0 times I gives you the same thing. Okay, and of course cos 2 pi is equal to 1. So obviously you can see that exponential I 2 pi will still give you equal to 1. Of course you can actually continue to pick all of these values, but then you will notice that whenever you have this exponential equation, that exponential I2k pi is actually going to be giving you equal to 1. That is for all integer values of k. Okay, so this is just pretty much cool. When of course if our theta changes to 2k pi, where k is just an element of integers, this exponential equation, this polar exponential equation, will always give you equal to 1. So in order for us to solve the problem we want to solve, we're just going to be making this substitution, and of course in place of 1 we're going to be replacing we're going to be writing exponential I 2k pi. Okay, so that tells us that the equation we're now solving is 1 exponential x equal to 3 now changes to exponential I 2k pi. Okay, and then of course power x is now equal to 3. Okay, so we can then proceed to solve from here. We can actually use this x to multiply the stuff we have right here, and if we do that, we're going to be having exponential I 2k pi x is equal to 3. Okay, So like we've always done, we're going to be taking the natural log of both sides so that we can bring all of this stuff down here. Okay, so we have natural log of exponential I2k pi x. Okay, and of course it's equal to the natural log of 3. Okay, so utilizing the property of logarithm, I'm going to bring all of this down so that I have that this will give me I2k pi x natural log of e is equal to the natural log of 3, and obviously natural log of e is equal to 1. So 1 times this stuff right here, I'm left with I2k pi x is now equal to the natural log of 3. Okay, and of course because we are looking for this x right here, we're just going to go ahead to divide through by the coefficient of s, which is just I 2k pi. Okay, I 2k pi. So this is actually going to cancel these ones, and then we are left with x equal to the natural log of 3 divided by I 2k pi. Okay, so this is cool. The next thing we want to do is actually to go ahead and then simplify this further so that this I right here comes to the numerator, and it is just as simple as multiplying both the numerator and then the denominator by I, so that when we do that, this I times I here gives us minus 1. So I'm going to be having the minus comes to the numerator, and of course I times natural log of 3 give us I natural log of 3 divided by, so we now have 2k pi at the denominator, and this is actually going to be the value of s that will satisfy the problem we are solving. Let me know if you've enjoyed this video. That is a cool way for you to actually simplify similar problems, and then of course if you have any question, do drop it in the comment box and I will surely look at that. So thank you guys so much for watching. Ensure you like this video, subscribe to our channel, and then I'm going to see you guys in my next video. Bye.